differentiation of y equals a to the power of x. A to the power of x is called exponential function. So this is differentiation of exponential function. Why do we call y equals a to the power of x exponential function? In English language, y to the power 1 is a script. So that's a script. A is also a script. The x, the power of x, is what we call superscript. So that x here is a superscript. And the a here is a script. So that's a script as well. But in maths, we called that's a base y to the power 1, which is y, and base a to power x. So the superscript is called power in maths. So that's power. Or you can call it index, or the important one is exponent. So that's exponent. And if the variable is an exponent, we call it exponential function. So because the variable x, a is a constant, give an example, y equals 2 to the power of x. A is a constant. A constant means, in this case, it doesn't change. But x will change, hence we call it variables. Because it's changing, it's a function. And therefore, and it's in exponent, it's in the power, it's an exponent, so therefore it's exponential function. So that is exponential. So that's why we call it an exponential function. So we're going to differentiate exponential function. To do that, we could start with, we know y equals a exponent x. So what we can do is to say, let a equals e to the power of k. What we've seen this is now I can rewrite my y in terms of e to the power of k because a is e to the power of k. So I can replace a with e to the power of k. So y equals e to the power of k all to power x. In indices, we can see that if we have b to the power of n all to the power of m, that can be b to the power of n m. And m means n times m. So that's multiplication. So therefore, we get y equals e to the power of kx. So what we're going to do now is to try and differentiate e to the power of kx. We know that when we differentiate y equals e to the power of a function, and that f is a function of x, then the y, the x, is equal to e to the power of that function times differential of f over differential of x, the f, the x, because that's f is a function of x. So that's the differential of y equals e to the power of f. I need to then differentiate y equals e to the power of kx. So the differential of that would be, well, first of all, my f equals kx, right? So the f over the x, you can see f is a function of x. So the f, the x, equals, we know that if y equals x to the power of n, then the y, the x, equals n x to the power n minus 1. So that's the basic differentiation, the first differentiation that we know. And now we're going to apply that here. So that would be 1 times k, because there's 1 here. So 1 times k, and that will give you k. Then that will be 1 minus 1. 1 minus 1. So that will be x to the power 1 minus 1, and that's 0. So that will be the f. That implies that the f over the x equals k x to the power 0. And we know what x to the power 0 is. X to the power 0 equals 1. Anything to the power of 0 is 1. So that equals k. So now we've got the f, the x. Now we need to multiply that to e to the power f. So the y dx, when y equals e to the power kx, will be equal to basically e to the power of kx, which is the f, times the f, the x. And the f, the x is k, so times k. So we can write it as, that implies that the y, the x, equals k e to the power kx. Now we need to remember that a equals e to the power of k. Therefore, I'm going to, if a is equal to e to the power of k, let me just write it here. A equals e to the power of k, because I need to put x here. So if I multiply that by power of x, remember bn to the power of m, b to the power of n, all to the power of m is b and m. So you can see that will be e kx. Well, if I do that here, I have to do the same thing here. So therefore, e to the power of kx is equal to a to the power of x. So that means the differential here equals k times a to the power of x. You can see e to the power of kx equals a to the power of x. Therefore, k times ax equals k times e to the power of kx. Now, what is k? We know that a equals e to the power of k. This is base e to the power of k. I'm going to multiply both sides by logarithm of log of base e, because the reason why I'm using base e is because this is e. This is base e here. So I'm going to multiply that to by log of base e. So this is, by the way, you can write log as log of base e. Same thing. What I need to explain is, what is log of base e? Log or base e is also called ln. What ln is? Natural log. Now, log of base e of e is actually 1. So if you see ln of e equals 1. If you punch that into calculator, you will see you get 1. And I'm going to input ln of e, alpha, and then press times 10 to the power 10. That gives you e, close the bracket, and equals, you get 1. Let's do logarithm as well. So cancel that. That's log base of e, alpha, then that will give you e. Then move your cursor and then put alpha e again, press equals, you get 1. Log of base e to e is 1. Likewise, log of a to a will also be 1. But in this case, so now that's what I've got here, because I've multiplied by log e of a equals log base e to e of k. But I need to rewrite that one, because log of e to a is equal to, let me just write it clearly. So e to power k. I'm going to use something called power law. Power law says that if you have an exponent in front and you have a log, you can bring the exponent to the front of the log. So we can have log of e a equals k log of base e to e. And that meant that log of e equals 1, right? So that will be just k. So k equals log e of a. But what is log of e? Log of e is ln. So therefore, k equals ln a. So that's what k is, ln a. Now, I'm just going to replace k here with ln a. So therefore, the y, the x, will be equal to, well, I'm going to write that first, a to the power of x ln a, where y equals a to the power of x. So that's the differential of, if you differentiate y equals a to the power of x, or an exponential function, this is what you will get. The y dx, or derivative of a to the power of x, equals a to the power of x ln a. So let's do an example. Y equals 2 to the power of x. Then the y dx will be equal to, well, we're going to get the 2 to the power of x back ln a. A is 2. So the differential of y equals 2 to the power of x, and the y dx will be a is 2, so you put 2 there, and x is the variable, put the x there, ln a ln 2. That's it.